Welcome to The Explainer. Today, we are giving your C++ programs a memory, for real. We're going to master one of the most fundamental and honestly most powerful tools you have, reading from and writing to files. All right, let's just jump right in with a question every single one of us is hit up against. You build this awesome program, it's crunching numbers, it's holding on to user info, and then you close it. Where does all that stuff actually go? Yeah, the tough answer? Nowhere. Poof, it just disappears. All those variables, all that data you carefully put into the computer's memory, it's all temporary. The second your program stops, that memory gets wiped clean. So this right here, this is what we call the persistence problem. How in the world do we make our data stick around, persist, after the program is done? Well, today, we're going to solve that exact problem using C++ file I/O. We're going to let our programs save their state for good. Okay, so the big idea behind all of this is something called a stream. And it's a really brilliant concept, actually. The best way to think about it is like a data pipeline. Data flows from one place to another. And the cool thing is, the stream doesn't really care if that data is coming from your keyboard or going to a file on your hard drive. It just manages the flow. And here's the kicker, the part you might not have even realized. You've already been using streams this whole time. Seriously. Every single time you've used sin to get input or count to print something, you were using I/O stream. That's a stream from the keyboard to the screen. All we're doing with files is just changing the endpoints. We're using the fstream library to point that same pipeline to a file instead. It's the same exact idea, just a new destination. Okay, so let's tackle the first piece of this puzzle. How do we get data that's sitting in a file into our program, right into memory, so we can actually do something with it? And you're going to love this, because C++ makes it super logical. It's a simple, easy-to-remember three-step dance you'll do every time. Open the file, read the data, and close the file. Open, read, close. Let's walk through it. All right, step 1, open. To do this, we use an object called an input file stream, or ifstream for short. This little guy is what makes the connection. You just create one, tell it the name of the file you want to read, and bam, it builds that data pipeline from the file right into your program. Next up, step 2, read. And this is where C++ is just elegant. It works exactly like sin. No new syntax to learn. You use the exact same extraction operator, those two greater than signs, to pull data out of that file stream and pop it right into your variables. It's that consistency that makes this so easy to pick up. And last but absolutely not least, step 3, close. This is a super important habit to get into. You have to call the .close method. Why? Because it's your way of telling the operating system, hey, I'm done with this file, you can have it back. This frees it up so other programs can use it. It's just good programming hygiene, like hanging up the phone when you're done with a call. Okay, great. We can get data in, but that's only half the story, right? Let's flip this around. How do we save our program's results out to a file so they stick around? And guess what? You're about to see a very familiar pattern. The process for writing is almost a mirror image of reading. It's open, write, and close. That seems simple three-step logic is back. So for writing, instead of an if stream, we use an OF stream, an output file stream. And this has a really handy feature built in. When you tell it to open a file, like results.txt, if that file doesn't already exist, C++ just creates it for you. Pretty convenient, right? But, and this is a big but, you need to be super careful here. By default, if that file does already exist, opening it with OFstream will completely erase everything inside it. It's designed to give you a clean slate, which can be useful, but man, you have to be aware of it or you could accidentally delete a ton of important data. And here we go again with that beautiful C++ consistency. To write your data to the file, you use the exact same operator you use for count, the insertion operator, those two less than signs. It's the same command. You're just telling that stream of data to go to a file instead of to your screen. And you guessed it, we close the file. Now, when you're writing, this step is even more critical. See, sometimes your program holds data in a temporary buffer before writing it to the disk. Calling .close forces everything in that buffer to be written out for good. If you forget this, you could end up with a file that's empty or missing the last few things you tried to save. So don't skip it. Okay, theory's done. We know how to read, we know how to write. Let's put it all together and see it in action with a really practical example. Just copying a file from one place to another. So, the goal is simple. We've got a file called input.txt that has some text in it, and our program's job is just to read every line from that input file and write it line for line into a new file called output.txt. Basically, we're making a perfect copy. The logic here is just a mashup of the two things we just learned. It's really straightforward. First, you open input.txt for reading. Then you open output.txt for writing. After that, you just loop. Inside the loop, you read one line from the input, write that same line to the output, and you just keep doing that until there's nothing left to read. And at the very end, you close both files. See? It's that open, process, close pattern all over again.
So, the big takeaway here, you now have the solution to that persistence problem we talked about at the beginning. That's huge. By using ifstream and outstream, you've literally given your programs a memory. They can remember things from one run to the next. They can save data. They can build on what they did before.
And this one skill, it just blows the doors open on what you can build. I mean, think about it. Now you can save a player's progress in a game. You can create log files to track what your program is doing. You can store user settings. You can even start to process huge data sets that would never fit in memory. This is the skill that takes a program from being a simple one-off script to being a real powerful application. So the question is, what are you going to build?